Hello everybody, I am Mr. Adhar with the physics pages and I am going to start physics paper 2 variant 22 May June 2024 for the extended version. So let's start the exam. Question number 1. A student wishes to measure accurately the volume of the approximately 40 cubic centimeter of water. She has two measuring cylinders, a larger one that can hold 100 cubic centimeter and a smaller one that can hold up to 50 cubic centimeter. This one is the larger one that can hold up to 100 cubic centimeter and this one is up to 50 cubic centimeter. The water forms a meniscus that it touches the glass. Whenever we are going to measure, we have to take bottom meniscus for this. And secondly, I would like to remind you, as the cylinder is bigger, the scales on the cylinder will not be that fine. For example, if I draw the scale here and if I draw the scale here, the smaller one will have more fine scale and this will have large scale. The smaller scale or smaller cylinder will be more, you can say, accurate and also will be more precise or you can say sensitive. So this one is more sensitive because it can give you the minor details as compared to the larger one. The larger one will give you as a whole large volume, but the small details you can see will be from the smaller one. Coming back to the point, which cylinder and which water level does the student use to ensure an accurate result? As I mentioned, the cylinder will be smaller one, so smaller one with the bottom of meniscus, not the top of the meniscus. So bottom of the meniscus is better. Question number 2. The motion of an object is represented by the speed time graph, speed on y-axis, time on x-axis. Whenever we have a speed time graph and in which the line is a straight line, so you can say speed is increasing with respect to time with a constant rate, so acceleration will be zero in this case. We can just simply say, for example, this graph shows no speed, speed is zero. This graph with the speed time, if it is like this is with a constant rate, speed is increasing, acceleration is zero. This one, acceleration is increasing. This one with the speed and time, the last one, if this is like this, it is accelerating but acceleration is decreasing with the rate. Now the question comes, which quantity is equal to the area under the graph? So area under the graph is this trapezium and we are aware that area under the graph, a speed time graph, is always used to measure the distance traveled by the object. Question number 3. An astronaut of mass 80 kg is standing on a planet with a gravitational field strength of 3.8 Newton per kilogram. What is the weight of the astronaut on the planet? For the equation of the weight, we know that weight is represented by the W and W is always equal to mass m times the gravitational field strength G. So you need to find weight. So weight W is equal to mass of 80 kg times 3.8 Newton per kg. It gives me 304 and unit of the weight is kilogram. In two significant figures, we know that it will be 300. So correct option is B. A sealed container of volume 2000 cubic centimeter contains air at high pressure. The container is placed on the top of top pan balance. The balance reads 200 grams. So all the air is removed. When air is removed by the vacuum pump, the balance reads 196 grams. Mass of air, mass of the container with air minus mass without air. So mass with air was 200 grams minus 196 grams. So mass of the air is 4 gram. Now what is the density? The equation for the density, we know that density is denoted by rho. It is always equal to mass divided by volume. So finding the density, I have a mass of 4 gram over volume 2000 cubic centimeter. So it gives me 1 over 500, so that is 0.002 gram per cubic centimeter. That's our option A. Question number 5. Each diagram shows three forces on a beam. We know that beam is a regular in shape, so its mass is distributed equally throughout the beam bar. In which situation is it possible for the three forces shown to be in equilibrium? Before I start, I just need to talk about the equilibrium state has two conditions. Those two conditions are sum of all the forces, or you can say resultant force is zero. Resultant force is always equal to zero. What does it mean? It means that the sum of forces upward or the sum of forces downward are equal. Sum of forces leftward or sum of forces downward are equal. So before I go for the second condition, if we look at these diagrams A, B, C, D, I can see in figure A or option A, upward is a single force which is large in the length. It means the length of the upward force is more. This force, let's say F1, whereas the downward forces here are smaller and looks like these are half in magnitude, so F2 and F3 equally, when we add them up, are balanced to F1. So resultant force 0 mean the forces upward are balanced by downward. So this one shows that F1 will balance by the sum of downward forces F2 and F3. So resultant will be 0. So in this case, resultant force is 0. So this option is quite better to choose. For the first condition I'm talking about. But in second, all of the forces F1, F2 and F3 looks similar in the length. And also we can see that F1 is upward, F2 and F3 are at some angle. So if, for example, we say that the angle of F3 and F2 are equal, so still these two forces can balance each other. So I can say F2 balances F3. So F1 will move it upward. So this condition say that this bar has a force upward, so it is not in equilibrium. Similarly, C, you can say this F1 and F2 almost equal in magnitude and they can balance each other, but still F3 is an extra force that can make it move upward. So this is also out of the chance to get in equilibrium. Moving to D part, for the first condition, it's the same condition. We can see this F1, this is F3, both when we add up result equal to F2. So upward forces F1 and F3 which are equal in magnitude when we add them to F2. So it is balanced. So when it is balanced, so there is resultant force is equal to 0. So I have an option either A correct or D correct according to first condition of equilibrium. But when I move to second condition of equilibrium, second condition of equilibrium says resultant movement is equal to 0. Resultant movement is 0 can be explained like clockwise movement should be equal to anti-clockwise movement. So clockwise and anti-clockwise movement can be found if we have a point around which the object is moving. You can say center of gravity or you can say pivot point. So for these two figures which are having a chance of beam to be in balance like A and D, sorry. So for A, let me check for the rotation F. For this one, I am taking this point as pivot. So whenever any object is having a pivot, a force on the pivot will have no rotation. So this force A will have no rotation, but F2 has a rotation that is clockwise, F3. So F1 rotation, but as a whole, this object has clockwise rotation. So this has a clockwise rotation, so this is out of the chance. So the only option D left that will surely be our answer, but before that I need to check for it. I take F3 as a pivot point. So when I take this F3 as a pivot point, F3 no movement, no rotation. F2 will have a rotation that is anti-clockwise, and you can see this distance is small and force is large, whereas F1 will have a clockwise rotation with larger distance from here till the pivot and smaller the force. So there is a chance that clockwise movement will be equal to anti-clockwise movement, but there is none of the other options that seems to be correct. So the only correct option for this question seems to be D. But if the values are given, then it will be more accurate to find. Question number 6. A gymnast jumps down from a high piece of apparatus. She gradually bends her knee as she lands. So we know that if there is a high apparatus and gymnast when she is trying to jump, what happens in the middle? The legs are bent. So why they are bending, or what's the reason behind it? We have to know. She gradually bends the knees as she lands. Which effect does this have? So as she is going to hit the ground, it means that the bent knees will make the time taken an increase. So she is trying to increase the contact time with the ground. As the contact time increases, we know that according to the concept of the impulse or change in momentum, that force in time taken when multiplied, we get impulse. So if time taken is increased, automatically the force effect or the damage will reduce. So she is trying to increase the contact time to reduce the impact of the force or smaller the force. So she will have a smaller change in momentum. No, it's not possible. She will lose the kinetic energy. There is law of conservation of energy says energy loss is not possible. It can convert only. She will exert smaller impulse. No, she is not going to change the impulse, but she will experience a smaller force when she will have a contact with the ground because the time is increased. The table gives four energy resources and states whether the main source of energy for the resource is the sun. So, major source of the energy resources, sun is the major source. But when we talk about geothermal energy, we know that the sun is not, the earth's temperature is the main source, you can say. Oil, yes, sun is not the main source. Sea is water held behind a dam. Yes, when water is held behind a dam, it has an energy, and energy is basically the tidal pull that is created by the sun. Yes, it is correct. Wind is also provided because of the sun, because sun creates the temperature change in the two places, and convection current flows to blow the big wind. So it is yes, and it is water behind the dam. The equation delta P is equal to rho GH. Delta P is for the change in pressure, rho is for the density, G is gravitational force, or you can say gravitational field acceleration or gravitational field strength. Delta H is the change in height. What is the meaning of the term rho? Rho is representing the density, as I mentioned. What are the correct terms for each change of state? Solidification is the liquid to solid. Yes, it is liquid to solid. Condensation is a process when gas converts into liquid. So this one is wrong. Liquid to solid, melting, no, melting is not liquid to solid. It is solid to liquid, like solid oils to this. Liquid to solid, solidification, as I told you, yes. And liquid to gas is evaporation. Yes, it is evaporation. So part C is correct. So liquid to solid melting is wrong. So it is not possible. Question number 10. Extremely small pollen grains in water are viewed through microscope. The grains are seen to move gradually and randomly. We name this motion as Brownian motion. Brownian movement. What is the reason for this random movement? Let me show you here. If this is a container filled of water, So if you drop some pollen grains, you can see these pollen grains looks like move in this zigzag path. So this is called Brownian movement. What is the reason for the random movement? The grain are moved by randomly moving water molecules. Yes, water molecules are always in the random motion, and these water molecules, when collide with the grains, so they always keep on pushing the grains. When these keep on pushing, so the grains sometimes move left, right, up, down, so they keep on changing the direction. Part B says, option B says, sorry, the grains are moved by random convection currents. No, convection current are not affected. Convection current occur when there is a difference of temperature, but in this question there is no temperature difference mentioned. The grain are moved by random rays of light reflecting off them. No, rays of light are not going to give them motion. The grains are moved by the random motion of their own atoms. So, own atom are not. I think so. Option A is correct. 11. Which graph shows how the volume of fixed mass of a gas at constant temperature varies with its pressure? So, if you have a fixed mass of a gas and it is inside a container that has a constant temperature, T is constant. So, what happens is as the pressure increases, the volume may decrease. So if initial volume is this V1, pressure is P1. As the pressure increases and becomes P2, the volume will reduce to V2. So pressure increases, volume decreases quickly to compensate the temperature constant. Or in other words, we can say to keep the temperature constant, the volume reduces as the pressure increases. So until there is a situation that further increase of pressure will not affect the volume. At that point, uh, the gas cannot have a decreased volume. So that is the fixed gas volume that cannot be further decreased. So in this case, option A, we can say pressure increasing the volume exponentially. This is not correct. Pressure and volume are directly, both are increasing, but here we saw that pressure and volume are inversely proportional at constant temperature. So this was the statement of the Boyle's law. P1 V1 is equal to P2 V2, or you can say pressure and volume are inversely proportional. This is Boyle's law. Moving to C, yes, it is volume decreasing with the increase in pressure, but this one is a constant rate, and when uh, the pressure is maximum, volume is going to be zero. This is not related to the real life situation. The real life situation you can see is option D. Why? Because initially with a smaller change in volume, pressure, volume decreases, but at some point you keep on increasing the pressure, there is no further decrease because this is the maximum decrease in volume. So this is the minimum volume that a gas can contain. So this is it. So option D is the correct option. Which effect is caused by the thermal expansion? We know that thermal expansion is expansion of solids. When we heat up, it can be a linear expansion or can be a volumetric expansion in length or in volume. A metal surface heating up in direct sunlight, yes, it is gaining heat, but this is not showing any effect of expansion. So this is not our choice. Ice cream melting on a hot day. When ice melts or ice cream melts, it converts into liquid, but there is no thermal expansion shown while melting. A railway track is buckling on a hot day. It means railway track expands and it changes its volume as well and length as well. So yes, this is expansion due to the heat caused. So this one is true. Ice forming on a pond on a cold day. Whenever there is a cold day, ice is formed on the pond. That is liquid convert into ice, but there is no expansion seen here. So option C is our right choice. Question number 13. The temperature of water at the bottom of the waterfall is greater than the temperature of the water at the top. For example, this is a waterfall, and in this waterfall, this is the stream. So, in this waterfall, this temperature is low and this temperature is high. So, temperature increases as it goes down. The energy of the gravitational potential store of the water at the top is transferred to the thermal store at the bottom. So here it is potential energy stored that changes to thermal energy at its core. So according to law of conservation of energy, energy converts from one form to another form, but there is no loss in energy. So all of the potential energy is going to change in thermal energy. The specific heat capacity is 4200 joule per kilogram per Celsius. What is the temperature difference for the waterfall? So we need to start with the first thing. The equation for the potential energy we know that is mg delta H, whereas thermal energy is mc delta T. Here mass of the water is constant, it's cut. We are going to find the change in temperature here. So change in temperature will be G times increase, or you can say height over specific heat. So I can just simply substitute the values. Change in temperature is 9.8 times 21 over 4200 joule per kilogram Celsius, and the answer is option B, 0.049 Celsius. 14. An ice cube is placed in a beaker and is heated. The ice melts to form water. Melting of ice is a process of phase change. Yes, heat is gained, but there is a change in phase. So all the heat is utilized to change ice into water. So heat gained is used in the phase change, which evaporates at first and then boils. So evaporation is a process of phase change. Yes, heat gained, but phase change. So here, in both cases, heat gain, and boiling is also heat gain. So melting, evaporation, and boiling all are gaining heat from the surrounding or from you can say from the sources or surrounding. The steam condenses, so steam is going to convert into liquid again on a cold window. So this is the process in which heat is lost to surrounding. So this is the only process in which heat is given to the surrounding. The previous one heat were gaining by the liquid or solid ice or something, which process involves transfer of energy from ice, water, or steam to the surrounding. So, ice to water was heat gain, water to steam, heat gain by the water, evaporation, heat gain. Only condensation is a process that is releasing heat to convert gaseous uh, state of the water to the liquid state. So we have the process of condensing, better choice. A teacher shows his class polystyrene cup. The polystyrene is a thick plastic with lots of tiny air bubbles in it. He asked the class why the cup is so good at keeping a hot drink warm. Three suggestions are made. It contains air, which is a poor thermal conductor. Of course, a solid is the best conductor of the heat, whereas air is not that good conductor. The air is trapped in tiny bubbles, so very little convection is possible. Yes, convection current possible when air molecules are free to move and take the heat from one point to another point. So this looks also good. This looks also good. The plastic is a poor thermal conductor. Yes, you can say metal is a good conductor, plastic is a bad conductor. So for me, all of these three are the good suggestions. So which suggestions are correct? All 1, 2, and 3 are correct suggestions. Question number 16. The two samples of the same material have the same mass but different surface areas. You can see the surface area. This uh, is a circular, and it is mentioned it's a small surface area, and this one is a large cubical surface area. Each sample is heated. We heat this one that has same material and same mass, but the volume is different. We heat them, heat this one and heat this one. For example, we are heating them, heating them. So with the same temperature, up to the same temperature, and then let it cool to room temperature. For the cooling, we know that there are few factors that affect. Number one, surface area is very important. More surface area will cool quicker. Secondly, air and some other factors are also, if when a wind is blowing more, it can cool easily, or surrounding is gaining more, cool easily. Now each sample is allowed to cool to the final temperature, which is also same final temperature. So for me, if we are going to find which one is going to cool quickly, so for me, why will cool quickly? Because its surface area is large, then it will release the heat quickly. But let's see what the question is saying. Which row correctly compares the decrease in internal energy and initial rate of cooling for the each sample? First of all, when you allow same heat to enter and allow same heat to release, so for me, increase and decrease in internal energy will be the same. Why? Because you are heating them to the same temperature and you are allowing them to the same final temperature. So internal energy initially increases at the same rate and decreases at the same rate. But initial rate of cooling depend on the surface area. So for me, this large surface area will have a faster cooling rate, so as compared to the small circular one. So decrease in internal energy, for me it's the same. So option C and D will be the right choice. Now, for me, this Y is going to cool quickly. So Y cools faster. This option. So correct option is D. In which type of wave is direction of the vibration parallel to the direction of travel? We know that there are two type of wave. One type of wave is this one, in which vibration and the direction of propagation are perpendicular. This is called transverse. The other is like compressed slinky spring or the sound wave, in which particle motion and the vibration are parallel. These are called longitudinal waves. So this question is for the parallel, actually asking for the longitudinal waves. So here electromagnetic wave can be transverse and longitudinal both, because these are the wave that does not require medium but they can travel, and most of the time if you talk about light waves, these are transverse waves. Seismic pressure wave moves the vibration in the form of in the parallel direction like longitudinal wave. Seismic S wave, transfer wave, water wave are transfer wave. So here, which one is the parallel longitudinal wave? Option B is the correct option. Waves in a ripple tank are diffracted as they pass through the narrow gap. In ripple tank, we know that these are the wave fronts, and this is a gap, narrow gap, and this one is the diffraction phenomena. First thing we have to remember, the wavelength of the wave should be compared to the size of the gap. So wavelength should be approximately equal to the gap size of the slit, or the length of the side. If we reduce this wavelength and gap stays the same, in that case, what happens is diffraction phenomena becomes minor or almost invisible. If I increase the wavelength and gap is smaller, then diffraction phenomena will be more visible, more accurate. So, to have a diffraction phenomena, the slit or the gap size should be at least equal to the wavelength. And here, one more thing that I need to mention is the wavelength and the frequency are inversely related. If frequency is increased, wavelength is decreased. If frequency decreases, wavelength increases. So, for diffraction, I need more wavelength, mean less frequency. Diffraction is affected by the frequency or the wavelength. More wavelength, good diffraction as compared to the gap size, or less frequency, will be better. So option A, decrease in the frequency, yes, I agree. Keep the speed constant, yes, I agree. Decrease in the speed, I said speed will not affect. Increase in the frequency will decrease the wavelength, that is wrong. Increase in the frequency, so option A is our right option. Question number 19. Diagram 1 shows the page of the book in front of the plane mirror. This is the page of the book, this is the plane mirror, and eye looks at the image of the page. Eye is in the level of the page and image is seen. So for the plane mirror, we know that image is always virtual because it is cannot be seen on the screen, and it is virtual, same size, and laterally opposite. What does it mean? It means that left right will change, left and right will change, but up down will not change. So it can be having left to the right. Now, diagram 2 shows a large letter G on the page front in the mirror. So if this is G, so this up down remains same. So G will remain same as top and bottom, but left right will change. It means this side will move into this side. So you can see this may be, if I can draw, I'm not good at drawing, it can be like this, left right will change. What is the appearance of the image of G seen by the eye? This one is exactly similar, that is not possible. This is tilted to the right, this is wrong, this is upside down, this is wrong, up and down are okay, left right are changed, this is the option D. The diagram shows a ray of the light passing from the air into the diamond. This is air, this is diamond, and this is the boundary. What is the refractive index of the diamond? Refractive index is sine of the incident angles ratio with the sine of the refracted angle. So incident angle here in this case, if I draw the normal, so I can see this one is incident angle, that is 90 minus 60 is 30 degree, and 90 minus 78 is 12 degree. So I will find sine I over sine R, sine of 30 degree, because this is the incident ray, incident angle is 30, sine R is 12 degree. So 30 degree sine over 12 degree, it gives me 2.4. That is option C. 21. The ray diagram show the formation of an image by two different converging lenses. Which row describe the image produced? Uh, we need to remember one thing. The diagram 1 shows that this is the object and image is on the same side, and in the diagram 2 this is the object and image is on the other side. When image is on the other side, it will be real. For the converging lens, image on the same side that cannot be drawn on the screen is virtual. So we have to remember only image on the same side of the object is virtual and it is enlarged. Image on the other side of the object that can be drawn on the screen is real. So diagram 2 is real, diagram 1 is virtual. Option C. 22. White light enters a glass prism. Light leaves the other side of the prism is separated into two colors. White light is entering here and it's bending toward the normal. That is correct. But there is not a single sign shown for the refraction. But in the diagram 2, you can see the refraction is already started. When it will be on the other side, again this is more diffraction. So diagram 2 is the proper diagram. And whenever white light enters, our first color is red and last color is violet, because we know that from the color scheme, Roig wave. So violet is the last one. So which row correctly describe what happens? Path taken by the light is diagram 2. First one is red, last one is violet. So option C is the correct option. 23. The thermal radiation is a part of electromagnetic spectrum. What is the name of the region? Infrared region. A remote controlled vehicle is traveling on the surface of a planet. The vehicle senses an optical ahead. It sends a radio message to the control room from where it being controlled. The control room is 2.4 times 10 to the power 6 kilometers away from the vehicle. The control room sends a message back to the vehicle telling it to stop. What is the minimum time that elapsed between the vehicle sensing the obstacle and receiving the message? So let's say this is the vehicle, remote control vehicle, and this is the obstacle, and this is the signal sent to the control room. So this is, you can say, antenna, control room antenna. So this signal is traveling, control room then send the message back. So this, so the distance is actually two times than the actual distance. So it could be 4.8. We can say distance S or D, no problem, into 10 to the power 6 kilometers, but when I convert into meter, I need to multiply 1000 10 to the power 9 meter. Now you are asked to find time. We know that speed is equal to distance divided by time. So when you are finding the time, it is distance over speed, and distance is 4.8 times 10 to the power 9 meters, and speed is, it is speed of light, 3 into 10 to the power 8 meter per second, and the answer goes to 16 second. Which statement about the direction of the magnetic field at a point is correct? Direction of the magnetic field is always starting from the north pole to the south pole. At a point inside the magnetic field, north pole of any, uh, you can say, magnet will direct it the direction, like you have a compass always indicates the north pole of the magnetic field, so it is the direction of the force on an north pole of that point. 26. A student draws graph of an AC supply and a DC supply. DC supply is a direct current, and direct current, when it continues, it moves straight with the same value until the power supply is working. And this one is the voltage quadrant, voltage axis, and this one is the time axis. This is for the DC. But for an AC, voltage and time axis, we can see AC is always having positive and negative pulses, and it keep on changing. So for me, this straight line is showing DC, this Y is showing AC, and W is showing voltage. So here, which row shows the correct table? WXY. W, I told you, is voltage. AC is Y, DC is X. Option D is the right choice. A resistor transfers 100 joule of energy when a charge of 10 coulomb flows through it. What is the potential difference? Potential difference, we know that work done per coulomb of charge or energy delivered for per coulomb of charge. So energy is 100 joule and charge is 10 coulomb. So that is 10 joule per coulomb. That is also called volt. Wire X and wire Y are made for the same from the same material. So material is the same. The given information about the two wires, length of X is 1, cross-section area is 0.4 millimeter square and the resistance is 2.0. Wire 2 is length 1.3 increased but that cross-sectional area is decreased. So we have to find the resistance. We know that the material is same, it means the resistivity is same and resistivity is resistance cross-sectional area over length. So for one material, resistance of the first material, cross-sectional area of the, I can say wire X, X and X will be equal to Ry, Ay over Ly. I need to find Ry, so I can just simply say that resistance of Y is Rx Ax times Ly over Lx times Ay. Here, units for the length are meter, for the area are meter square. So above and down same. So resistance of wire Y will be in ohm. So you don't need to change anything, any unit. Sorry. So Rx is 2 times 0.4 times length of the Y is 1.3 over length of the X is 1 and this is AY is 0.3. So it is 3.45, that is 3.5 ohms. 29. The diagram shows two resistors used as a potential divider. So the voltmeter reading is 1.8 volts. So of course across this one is from here till here is 1.2 volt because the total voltage is the sum of the voltages in these resistors, that is 3 volt. So what is the resistance R? So we know that current through them is same. So current through this one is same. Current is same. So definition of the current I is V over R. So here I can just say that voltage across resistor R over resistance R will be equal to voltage across resistor X and resistance X. So voltage across R is 1.8, resistance R we don't know, voltage is 1.2 over X is 5 kilo mean 5000. So I can just cross multiply them. I will get 1.2 R is equal to 1.8 times 5000. Just moving 1.2 on the other side, 1.8 times 5000 divided by 1.2. So my answer is 7,500. 7,500 is ohm in kilo ohm. I will divide it by 1000 and it is 7.5 kilo ohm. Two electrical appliances are connected to the main supply. The cable connected to one appliance includes an earth wire. The connected to the second appliance does not need any earth wire. What is the difference? Uh, Earth wire is required to avoid the short circuit or something like that, as any problem in the circuit or insulation. If it get heat up, insulation removes and wires get connected. So in that case, so if one appliance has the metal case and other appliance does not, that looks correct. One appliance is fitted with the fuse but the other appliance is not, no, this not be correct. One appliance is fitted with the switch but the other appliance, no, one appliance need more current than the other. Automatically when it will be short circuit current will this one. So here the correct choice is 31. The diagram shows a simple AC generator. The magnet rotates around a fixed coil wound round a fixed iron core. The EMF, electromotive force output, is a sine wave, a series of crest, zeros, and trough. The magnet is shown in three positions P, Q, and R during this rotation. The magnetic field in this coil is zero at Q, but changing most rapidly. Which statement about the induced EMF in the coil is correct? We know that induced EMF is dependent on the change in magnetic field lines. So from magnet position P to Q, magnetic field is changed, and from Q to R, it is completely changed again. Here, magnetic field lines are passing through this from north to south. In this way, magnetic field lines are perpendicular to the coil. So the change in magnetic field from maximum to zero is changing in a maximum condition. So as magnetic flux is maximum, so induced EMF is maximum. So magnetic magnitude of the EMF at position Q is larger than the position P. That seems to be correct. The magnitude of the EMF at position Q is zero. It can never be zero because it has a maximum change in magnetic field. Magnitude at Q is smaller than R. No, it can't be because it is the maximum change in flux. Magnitude of EMF at position R is larger than P. P and R will be the same. So option A is the right option. 32. A 24-volt power supply and a 100% efficient transformer are used to light 6-volt 12-watt lamp. 100% efficient means power in is equal to power out. What is the current in the power supply? We know that power is always equal to current time voltage. So I can just say that P is equal to I times V. When you are going to find current, or you can say EMF, E, so you can just simply say I is equal to P over EMF or voltage. Power is 12 and voltage is 24. So we can say it is zero point 0.5 ampere. The scattering of particle by gold foil provided scientists with an evidence of nuclear atom. Which particle were scattered? This is alpha scattering experiment with gold foil. So alpha particles were scattered. A nucleus has 17 proton and 18 neutron. So for any atom X, here is a proton number and here is nucleon number, and nucleon number is having nucleon plus proton, and here it has only proton. So 17 proton, you can say it atomic number 17, and mass number will be 17 plus 18, 35. So this is option D. The dashed line in a graph shows the decay curve recorded from a sample of particular radioactive isotope. The count rate includes background radiations. So this is dotted line that shows with the background. Which curve shows the corrected count rate for the decay? The corrected count rate will be less. So corrected is the permanent line, that is more here, it is impossible, so it will be less. And you can say there is a fixed value of the background radiations that you can see from this. So option B is the right choice. D is more, it is impossible. C is not right because the ratio of the count rate background is decreasing. Background radiation cannot be decreased, it will be the same. So option B is the right choice. Which type of radioactive source is suitable for measuring and controlling the thickness of a paper? For thickness of the paper, we use beta particle, beta rays. And the second thing, half-life for the beta particle should be the long, not a short. 37. A medical tracer is used to investigate tumor in patient. The graph of the corrected count rate from the tracer against time. These are the corrected count rate. There were 10,000 counts per second. And now, what is the half-life? Half-life is a time within which this 10,000 will change into 5,000. So the time starts from 0 to 2. So time is 2. So let us check further. From 5,000 to half is 2,500, and it should be in 2 more seconds, that is 4. So the half-life time is, this time is taken in the minutes. So you have 10,000 counts in the initial. After 2 minutes it's 5,000 counts, and after 4 minutes it's 2005. After 6 minutes it's 1250, and then it's so on. So our answer A is right choice. Half-life is 2 minutes. The earth orbits the sun once in 365 days. The average radius is 1.5 times 10 to the power 11. What is the average orbital speed? The orbital speed is always equal to 2 pi r over the time. 2 pi is constant, r is 1.5 times 10 to the power 11 meters. Over time is in the days, we need to convert it into seconds. So each day 24 hours, each hour 60 minutes, each minute 60 seconds. So when I divide it, I got 2.7 times this, that is approximately 3 into 10 to the power 4 meter per second. 39. Which statement about the life cycle of a star is correct? Option A. All stars eventually run out of the hydrogen as a fuel. Yes, of course, all stars run out of. A red giant forms a planetary nebula with supernova. Supernova is attached with red supergiant. A white dwarf or actually form a black hole. No, a white dwarf does not form a black hole. It forms a black dwarf, whereas supernova converts to a black hole. Expand and form protostar. Most stars expand to form red giant and red supergiant. So our option is A. Last question, number 40. A galaxy at a distance of 3.1 into 10 to the power 21 kilometer is moving away from the Earth at a speed of 7,000 kilometers per second. What is the Hubble constant? Hubble constant, denoted by HO, is equal to V over D. V, the speed is 7,000 kilometers per second over 3.1 times 10 to the power 21 kilometer. So Hubble constant is 2.3 times 10 to the power negative 18 per second. So either A or B. Now, using this data and what is the speed of galaxy at distance this, so you have to find speed. So let me remind you, Hubble constant is speed over distance. So if you need to find speed, so this will be Hubble constant into distance. So 2.3 times 10 to the power negative 18, and D is 6.2 times 10 to the power 21. When you multiply, your answer is 14,000. So that is option B. Thank you so much, guys. I hope you understand the explanation of all the questions. Please keep watching and subscribe my channel, The Physics Pages.